Okay, let's see if this works. So, I thought I'd make a small showcase for StationeersLUA and scripted screens. And yeah, to show a little bit of the stuff you can do with the software. And yeah, so I have two retro computers. One with a Lua debugger motherboard, one with a standard IC editor motherboard. And I think I'm too quiet. I think. Yeah, so this is the standard integrated circuit editor, but with the editor mod and with more lines, I think it's called. So you can disable the 90 characters per line limit, 128 line limit, and the 4096 byte limit. Otherwise, most of the Lua stuff won't work. Then I've got a standard console. This should work with the modular consoles mod. I haven't tried that yet. And a small little network, a pipe analyzer, a turbo volume pump, and gas tank storage. So just a small little network, and obviously a power source. So, what do you need the debugger for? Well, with the debugger you can see if your code has any errors, if you have some programming errors. You can have a log, so you could, for example, if you don't know how to work with the screens, or if you just want a single IC10 housing somewhere that does some stuff in the background and doesn't have a display, but should give some feedback on what's happening, you can use logs just by using the print statement, as I've done here. So if that's switched on and the screen gets initialized, it reports back the screen size. And in code it just says print with a string.format and then the size of the screen initialized. You can also look at the information, in this case the chip ID. It's okay, it's running without any errors. It's active, meaning it's currently running. So if we don't have a while loop or a tick function, and we will look at this later, then it will say active no. It just runs once and that's it. While it's running it shows active, and after that it's inactive. The dB setting is shown. That's like in for an IC housing you can set a value for the dB, or the device base, on the housing itself, and you have 31 memory addresses shown, as well as the SP and RA values. Since Lua in this case doesn't use the stack like IC10 does, it's still shown you still have the possibility to use this, just not in the way that IC10 code is using it, because IC10 code itself is a variant of MIPS, or assembly language, and Lua is, well, not assembly language. So, if we look at this, if we look at an old script of mine, which is in assembly, not an assembly, yeah, an assembly but in IC10, it looks like this. That's a completely standard IC10 code. Alias, define, and then you have well, not a loop itself, but in this case it's kind of a state machine that checks the RPM of the centrifuge, and as soon as it's over this limit, the 240, it will go to step 2. As soon as it's over 420 RPM, it will go into step 3. Or if that RPM goes down because the centrifuge is stopping, it will go back. That's an IC10. Lua code looks a bit different. Lua isn't a really hard language to learn. I think Lua is easier to learn than IC10. It is easier to write stuff with it and get your head around what things mean, what you can do with it, than IC10. And this framework, or this mod, these two mods actually, are showing that quite good. So you can essentially do everything you can do with IC10, but you can do a lot more, like interacting with screens, doing your own UIs. I mean, this is a very simple UI, but still. So you can do way more than with just IC10, and even stuff you can do with a standard IC10 code. With Lua, you can do it in less space, or with less bytes, and with an easier overview than IC10. Because IC10 only uses one instruction per line. You cannot have more than one instruction per line, and IC10 cannot create UIs. Yeah, so I thought, just for a small little showcase, I mean, I'm not Cows Are Evil or Elmotrix, so don't expect something big here. But I know my way around IC10. I know enough Lua to do some cool stuff. So I thought, well, I just start streaming and see what I can do. So we have a small network here. Just a tank storage, a pump, an analyzer. We also have a nitrogen tank and a pipe meter and a valve, but these are obviously not connected to a logic network. This valve is only for safety reasons, because the goal is to interface with this pump and fill a canister that's in there up to a certain pressure. So if I do something wrong and the pump is pumping in way too fast, I can just close the valve off before that tank explodes. Because an exploding tank is nothing, exploding pipe is nothing against an exploding tank. If a pipe bursts, well, it's unfortunate, but it may damage you, but it won't kill you. It won't destroy your base. An exploding canister, on the other hand, is like a bomb. Even if you overfill these pipes, they go up to 60 megapascal. Even if you overfill them to above 100 or 200 megapascal, they just burst and rip open. This thing, on the other hand, very dangerous. Okay, so let's see if we can do this, or how we can do this. So this is just to give a little overview here. This is a small little UI. That's the code for it. It's just 72 lines. So I'm just saying, I'm gonna copy that and put that into another window. so it's easier to see, or at least easier to visualize. Can I make this bigger? No. I can't make that bigger? Okay, yeah, I can do something like that. Just because the let's do it this way. So this may be too small for smartphones, but the coloring is better in Visual Studio. So what we're gonna do is we're gonna initialize a surface. You can have more than one surface. So for example, you can have a main surface and a settings surface, or a page, and you can switch between them. So you don't have to hide UI elements and show other elements. You can just say, okay, on the main page it shows all the information, and on a settings page you enter which devices it should connect to and so on. Then we activate that service, otherwise we wouldn't see anything. We get the size of the screen. A tablet, for example, has a different screen size as that console. A computer has a different screen size, and so on. We initialize two variables, W for width, H for height. I'm not checking here if these values are valid. So if I were to insert this chip into a housing which doesn't have a screen, these two would be nil, and it will throw an error. So that's very basic programming, but not safe programming. Then we clear the UI, meaning we just refresh the screen and clear everything that may be on the screen. Then we print screen initialized with the resolution. That's just a standard string.format. String.format is a very powerful Lua command. So this means %d x %d, meaning we have two integer values, or two parameters. The first one is this, w, the second one is h. %d will then just be replaced by the value. Also other ones like for floating point values, or for string, and so on. This is using Lua 5.2, by the way, so you can look at the real Lua 5.2 reference manual online, or you could ask your AI to help you with this, or to explain concepts of Lua to you. As far as I know, almost everything from Lua 5.2 is working with StationeersLUA, with the exception of I/O. So you cannot access your hard drive or values on your hard drive or something. You cannot access UDP streams or serial streams for safety reasons. So this whole script here is essentially running in a sandbox. As soon as you insert a chip, or as soon as the housing of the chip or the screen is switched on and has power, it's running a virtual machine that executes your code. And this virtual machine, as far as I know, cannot access your computer. Obviously, it's still possible to write malicious code. I mean, if we fill a tank with gas, yeah, you could write some code that at some point overfills the canister deliberately. or a code that locks you out of your station because it locks all airlocks or something. If they're on the same network, yeah, that works, especially in multiplayer. But it's not malicious code in the sense of remote code execution or accessing something on your hard drive. So, back to the code. We then get our first element, BG, the background. It's just a panel. There are different types of elements, panels, labels for text. We also have a table. There are charts. There's a bar chart, a line chart, a spark line, a gauge. They're customizable in different ways, or with different options. For example, with this table, we can set the header background, the header color, the row background, the alternating row background, the row color, the selected background, selected color, the font size, the row height. And these are not just fixed. So you can set them here, but you can change them afterwards. So you could, for example, say, hey, I want the user to be able to pick a different color. There is no color picker, but you could just do a text field and say, okay, enter your hex color code here. The user can enter the code, and then you just override that or set that value, that property. Or that style, rather. We have the columns, the ID, the display name, the reference ID, and the prefab hash. And here I'm doing something that's not normally possible only with this with these settings. I'm using a rich text tag, or a rich text TMP tag, or TMP rich text tag, one of the two. StationeersLUA is programmed in Unity, or is using the Unity game engine. And this engine has these TMP tags, Text Mesh Pro tags, and with using them, or with them, you can do stuff like align text, print text in bold, italic. You can practically format the text like in any text editor, or not a text editor, but in any word processor. But you can do pretty cool stuff. So if I go back to StationeersLUA and I switch to the left screen so you can see it all, you can see it too. If I use my device listener, move that to the motherboard and add 2 characters that it dropped off. Yeah, that's just the interpreter adding additional stuff, and that text then flows off the screen. Just ignore that. If you go to the logs, we now have that same view, but in print form. So this is just a print command. This is not a graphical user interface where I can define labels and bar charts and stuff. This is done completely without scripted screens. This is just StationeersLUA. And these are just 12 lines of code. This still shows the screen because I didn't clear the screen. And here I'm just using these TMP rich text tags to format the text. So I'm saying, okay, this text with practically the header should be underlined. That's the U. together with its closing tag. Should have an offset of 2 pixels, so the text is a little bit more over the line. And to get the exact positioning, because one problem of this is the font used is proportional, meaning each character has its own width. Like in Pipe Analyzer, the I is way smaller than the P, and even the uppercase P is wider than the lowercase p. This is completely fine for text, as long as it's not code, but for numbers, this is bad. Especially if you need to compare numbers, or if you have a value that's changing, it will always jitter. This fixes that. And in this case, we're just using the M space rich text tag, which just says, okay, the font that is used between this tag and this tag is now monospaced. So it doesn't change the font, but it changes the character spacing to be equal. Yeah, and then a lot of other stuff like position, to get the text to position right. And I had to use a new line here for this string format command. So this is all the same command. This is usually one line. I have to break that line here, because otherwise I wouldn't be able to see this part of the line. It would go off screen. And the editor, or not the editor, the interpreter would probably do the same thing that it did here. These two characters were cut off while loading. So we're at, if we look at the bottom left here, these two are the characters 91 and 92. So I didn't enforce the 90 characters per line limit, but internally it still uses it. So be sure to be under 90 characters per line, or you may get cut code or cropped code. And this is relatively easy to spot, but if you have a program with thousands of lines, and you have a couple of lines which are just cropped, and not only 2 characters, but maybe 10 characters, 15 characters, this can be code that is really hard to troubleshoot. Okay, so we're just printing, okay, I found this number of devices. We're using device list, which just gives you back a list of devices on the current network. And this code is only run once, and then it stops. Found %d devices, or found 5 devices, 10 devices, whatever amount you have on there. Then print a blank line and print a table header, and then go through every one of these devices and print the index in the list. This is a 1-based index, the display name, the reference ID, and a prefab hash. Word of caution: Lua uses 1-based indexes for arrays, for lists, and so on. There are two different types of indexing, for example, an array: 0-based and 1-based. 1-based means that the first element is the index 1. Like when you count something, when you say, okay, I have 4 apples, you have apple number 1, 2, 3, and 4. Other languages do this with a 0-based index. So the first apple has index number 0. So you're only counting 0, 1, 2, 3, but it's 4 apples. in StationeersLUA, if we look at that tank, or at that gas storage, no, gas storage, it has only one slot with index 0. This is a 0-based index. So, for example, if we take the battery charger, the big one, it has 5 slots, labeled from 1 to 5. Internally, they're labeled 0 to 4. So if you use a for next loop indexed with 1, you will get an error, because there is no index 5. So you have to use for example, you could use a normal for next loop, which goes from 1 to 5. You subtract 1 to index this slot, so this works. Or you just use a 0 to 4 for loop, or whatever you need, so that's something to look out for. Okay, yeah, the screen is now black. It cleared at some point. Okay, so close that. I'd say we look at, we use this one as a base. Or do we start from fresh? I think we start from fresh. So let's see, does this work? Oh yeah, this works, okay. So we have a new file. You can do this in every program you like. You could write this in Notepad or in WordPad or whatever. It's your choice. I'm using Visual Studio Code because in my eyes it's one of the best code editors there is. Not sponsored, by the way. Okay, let's see. Clear? No, not this one. Clear? So let's start from a clean slate. First, addressing. There are 2 ways to address devices. With standard IC10, you have 6 different devices that you can connect to one housing or one screen. So if you have a screwdriver and click on this screw, you can select 6 different devices. Once again, a 0-based index. In this case, this would work. We only have 2 different devices we need to interact with: the pump and the storage. But for different setups, for example, if you have, let's say, 5 filtrations and 5 tanks that need to be monitored, we're already at 10 devices. This is not working over this interface. That's too much. So the second way you can do this, and that's the way I'm going to be using, is by using the name of the device. So that's the gas tank storage. We're going to copy that into the clipboard. And that's a turbo volume pump. That's a bit too long. So that's the first one. Just call it pump. So what I'm doing here is defining 2 devices. Dash dash means it's a comment. Everything after that will be ignored. Now, how do I assign these devices? Well, there is a command I have to... I have to... or I can... Wait a second, I can do that in... I can do that here as well. Guides. StationeersLUA guide. Let's see if this is in here. No, probably not. I think that's just a simple guide. No, core API? No, probably not. Okay. Yeah, there's an online guide. Let's see. There it is. There's a so-called IC command. IC.find, followed by the name of the device. So in this case it's gas tank storage and pump. So we now have two devices, GTS and PMP. You could use different names, you could use longer or shorter names. Good advice or good practice would be to use a name or an identifier that's easy to follow. So GTS, gas tank storage, okay, makes sense. You could do something like this, but the problem is knowing that this garbled text means gas tank storage is a bit hard. It does work as long as you keep keep referring to the same text. It's no problem. Lua will work with this. Lua doesn't care how you name your devices, but for maintenance, this is bad. But then again, it's your code, so do what you want. Okay, now we could print these devices. So I'm saying GTS is %D and PMP is %D, followed by GTS and PMP. Now if we copy that and try that out, what? Oh, yeah, I forgot. Yeah, I think I know what the problem is. Yeah, that's a problem. Problem is that these tags still exist. So U, for example, is closed with /U, but the rest isn't. So let's see, pull 0. Let's see if that works too. V offset M space within use. Okay, let's see if that works. Not copy. Clear. Nope. Oh shit! I know why it's not working. Stupid me. String.format, obviously. Yeah, now it's working. Okay. I thought it somehow incorporated these. Yeah, and I need to use string format, obviously, not print. Sorry. Okay. Just a short brain fart. Okay, so now we see our gas tank storage is ID 1043, the pump is ID 1052. Now that doesn't mean anything because we don't care what the ID is as long as it's there. For 1043 and the pump 1052. This is one case where you could say, okay, if there's an error in the program, you could use this print statement to see, hey, did it initialize correctly? Is there a pump in the network? Or did I, for example, forget to connect it? Because if I remove this cable, this pump isn't connected anymore. And I will now throw an error. Unknown at line 5. Because line 5 should print PMP. Yeah, PMP is nil, since it didn't find it. There is no log. But the snapshot says, runtime error, bad argument number 4. Number expected got nil. So if we do it now, it works. No errors. You could do, you could, for example, say, okay, if this device doesn't exist, if it's nil, then throw an error. Or if you're using a UI, you could say, okay, pop up a message and say, hey, this thing doesn't exist. I could do this, but it's just a simple script, so I won't do any error checking here, which isn't best practice, by the way. Okay, so we have a gas tank storage, we have our pump. I need to copy that and put that into here. Okay, because it's just easier to write here. Okay, now we need to define a couple of variables. LT, which again I have to look up, is this ic.enums.logic type and local LT LST, which is ic.enums.logic slot type. That's just a shorthand. If I now write LT, the program knows I mean ic.enums.logic type. Same for read. No, not that one. Okay, so slot type, logic type, slot type, and IC.read. So what we now could do is we could read our gas tank storage. Gas tanks? Yeah, gas tank storage. And the gas tank storage, in its logic, has a pressure and a temperature. We don't care about the temperature here, we just care about the pressure. It also has slots, but the slots also have a pressure. Difference being, this gas tank storage has no storage of its own, unlike, for example, a pipe. So if I pressurize this, these 7.47 megapascal are only in this pipe, not in this storage. If I now insert a canister into this, it gets filled from the pipe, not from this thing. So if I check the pressure of this gas tank storage, it should report 0, because there's nothing in it. So let's check that. Maybe stick to one program. So let's see. Local PRS for pressure equals read. Let's see. Device input output. Yeah, we have device. Where is it? By device index. A reference ID. We're not using a device index, we're using a reference ID. So read ID from GTS. And the type, well, LT dot pressure. Oops. This way. Yeah, PRS equals nothing. That's what I thought, because the pressure is 0. So if I get a handheld tablet, short dip in the network, the pressure is 0, meaning although it's pressurized, there's no pressure in it. If I now insert a canister, the pressure rises. Or there's a pressure. So the problem is, you cannot just say, okay, if the pressure of this tank, of the storage is 0, or is lower than the set point, then fill it. Because as soon as you get that canister out, the pressure will go to 0. So your script will try to fill this storage, and that won't happen. So at some point you will probably overpressurize that pipe. So what we need to check is if there is a gas canister in there or not. and only if there's a gas canister in there, then fill it. For this, we are reading the slot. I need another read. Read slot, isn't it? Slots and reagents? Yeah, read slot ID. That's too far. From GTS slot 0, we only have one. LST, sorry, logic slot type, pressure, or rather, occupied. Yeah, okay, it's empty. So, POS is nothing and SL1 is nothing. There's nothing in there. If I now put that in there, we get nothing back. Huh? Could it be that that isn't working? Read the pressure. Pressure. And occupied. No, GTS, gas tank storage. Oh. Yeah. Probably not a bad idea. Probably not a bad idea. To define a value it should print there. Jesus. Yeah. So the slot is occupied, 1, something in there, but the pressure is 0. If I take that out, it's 0. The slot is not occupied. So we can say, okay, if there's nothing in there, then don't do anything. Or, in other words, fill it only if there's something in there. Okay. Now we could also get the pressure directly from the canister. So pressure is read slot. Whoops. Logic starter efficiency? Oh. Yeah, LST pressure, not LT pressure. So if we fill that, no. Number is no integer represented. What? What? 15, okay. Oh yeah, because it's a it's a float. Not a, yeah. Oops. It's a float, not a, obviously the pressure is a float. So 362.76, well, kilopascal in this case. And it's occupied. Yeah, 363. Yeah, 362 probably. Yeah. And going down because it's cooling off. Quantity is 9.609, so quantity would probably also be interesting. Quantity. Now that's a float. Quantity 1. Oh, yeah. Yeah. I cannot read the quantity of that canister because that it's just with slots the quantity is just how much items are in this slot. Obviously you can only put one canister in there and that's it. I cannot put 2 canisters at the same time in there. So I need to read the quantity of the gas tank storage. So 9.61 moles. If we pull that out, 0. Okay. Yeah, 8.31 moles. So you can either say, okay, I want this much pressure in there, or this amount of moles of gas. I will go by pressure, because for me it's easier. For example, the jetpack I have 5,500 kilopascal, and I know, okay, this tank holds up to, I think, 10 megapascal or 10,000 kilopascal. This one, the smart one, I think up to 20,000, and the high volume, I think also up to 20,000 kilopascal. Obviously, if this tank heats up, the pressure rises. So, if you're on the moon, for example, and you have a sunstorm, and that canister is laying outside, it can overpressurize. Therefore, I don't fill it up to the limit. So that standard canister has a limit of 10,132.5 kilopascal or 10 megapascal. So I'll probably only fill it to around 9 megapascal. The other one, yeah, the smart one goes up to 20.2 megapascal. So 18 or 19 megapascal should be enough. And the high volume one goes to even 25 megapascal. So 20 megapascal would be absolutely enough. No need for more. But yeah, that's the gist of it. No, don't open that. Don't open that, please. Evacuate it. That's the basic gist of it. So now we have to incorporate that data into a UI. Okay, so let's see, UI guide, surfaces and views. No, where is it getting started? I'm just going to copy that from the original help. So we have our main service, we activate it, we get the size. We print the IDs. We initialize our values, or variables. We don't do that. Okay, now we need our elements. We need a background panel, a title, obviously not scripted screens, gas tank storage overview, let's see how that looks. Okay, not bad. But I want that text to be centered. So align, center, and I want a different color. So we copy that, go into Visual Studio, and this is a feature of Visual Studio Code. If there's a hex color code, you can pick a different color. The only problem is it's always in lowercase, and I prefer uppercase. So let's say we take a nice white. Yeah, that's also a live preview. Oops. So if I change this to 0, you see the color change. So D8E6DD is the color code we're going to use. Yeah, it looks good. Gas tank storage overview, so this is our overview, it shows nothing at all. Cool. Okay, but that's not all, we need more stuff. So let's see, what do we have? We have label panel progress. Let's start simple and use just a label. Maybe without the comment. For the ID, pressure. Now this ID is, in this case for the panel and for the label it's not really important. For this label it is. With this ID you can later reference to this label and change it. So for that reason that ID should be unique. Let's see, width. We can do it 10, 20. We start at 10. X is from left to right, Y is from top to bottom. It's this text, or this label starts at 10, has a height of 40, so that's 50. Plus 10 means we start at 60. Height of 40, yeah, it's okay. Width of W minus 20. W is the width of the screen. Align left. And the text will be something like PRS 0, just for testing purposes. So, there are two ways of in case probably three ways to have a main loop running that updates the data. A state machine, which is sort of like a while loop, or you can use a tick function. If you declare this function, then everything inside this function will be run every tick. You cannot use yield or sleep in this function. If you want to use yield or sleep, you have to use a loop, like for example a while loop. Okay, now local EL is UI get PRS. So we set the text of label to PRS code 0. Then we sleep 10 seconds. Then this tick takes over and sets the text to test. That's why I need an ID. EL is then just this element. So PRS 0. I should have used something less than 10 seconds. Yeah, I should have probably used 5 seconds or 2 seconds or something. Huh? Oh, yeah. Something isn't working. Question is what? Oh, now it's working. Okay. For some reason that sleep command is messing. Okay. Now PRS is the pressure. So we say PRS is 0, SL1 is 0, and quantity is 0. Then we read in live data. Read the pressure. String that format. Ooh, that's fast. Now we have the problem with a non-monospaced font. It jiggers. So we can solve that. Point 6. Better. Looks way better. Now we could also do this with a gauge display or with a progress bar display. Or not a progress bar display, a progress bar. And using string.format you can do the number of decimal places, the number of digits before the decimal place. There's a lot of stuff you can do. Okay. QTY for the quantity. Y 60, let's see, we have 60, we have a height, why do we have a height of 40? Oh yeah, because I'm using the wrong font size. So 60 plus 20 is 80, plus a difference of 10 is 90. Yeah. So if we pressurize that to, what was it? Oh, I think 10 megapascal or something. Yeah, 8. .8 megapascal. We have 233 moles in there. That's a lot. This one has 2.2 kilomole. Just to visualize that, that's 233. If we take this gas canister, what did I say, 8? Yeah, 229 moles. The same, obviously. Almost the same. But it gets higher. Let's do 18-ish. Yeah, 479, almost 480 moles. And this one, what was it? 25, okay. I'm gonna make the font a little bit bigger. Yeah, let's do 20-ish. .344 megapascal. That's 693, almost 700 moles in that tank. 700. We have 200 in this one. 233. So that's a stark difference. Okay, let's pump that back out. And while this is pumping up out, how about some gauge? In kilopascal? No, let's do megapascal. Maximum 20 or 22. Let's do 22. Now we have the props value, min, max, warn, danger, label, and unit. Unit is just unit it'll show. Value label is the pressure label. We have warn and danger, meaning at which percentage of the full range or the full scale the orange part, the warning part, begins. Let's see, 22 megapascal, let's say 20 should be warning. So 20 divided by 22 at 90-ish %. And at 95 we have danger, let's say danger at 90 and 85% is, or 80% is warning. This is called PRSG. So PRSG. Set props value to PRS. X10 Y, where's the pressure label? At Y60. That shouldn't go over all the way. Let's say this is only, I don't know, 150. So this can start at Y180. Yeah, and that's the wrong direction. Oh man, always happens. X Y60. Now obviously that's wrong, right? We have 0.7 kilopascal, that's not 0.4 megapascal. So we need PRS divided by 1000. Okay, so that thing is almost empty. $18 megapascal. Yeah, with the pipe, its pipe was empty. 15.7 megapascal. Yeah, 15.8 megapascal pressure, or 15,770.95. And that label is too small. So let's do a width of 200 pixels. So this starts at 210. That's practically it for the first almost 1.5 hour stream of creating a simple script with StationeersLUA and Stationeers scripted screens. Like I said, I know Elmotrix or Causa Evil would make a way better showcase, but hey, I'm not one of those two. So yeah, I hope you liked it. If you have any suggestions, leave a comment, and yeah, I will try. I will now try to make this, or not try. I will make this a little bit better display and so on. Maybe display even the type of canister that's in there, and then do the maximum pressure and this maximum pressure and the range of the gauge automatically based on what canister was put in. Yeah, so I hope this helped, and yeah, like I said, if you found it useful, then leave a comment, or if you have any suggestions, leave a comment, and yeah, have a nice day.